All right, so we have talked a lot about these centers of triangles. Well, we've looked at four different types of centers. So we're going to just review all of these in a nice little graphic organizer that you can have just to see them all side by side and kind of compare each one. So I'm just going to fill this out with you and review each of these a little bit. So the very first one that we talked about was circumcenter here. And a circumcenter is created by perpendicular bisectors. So just so you have this side by side. So perpendicular bisectors. So meaning when we're looking for a circumcenter, we're looking for these lines here that create a 90-degree angle, so they're perpendicular, and then they bisect, so they cut in half the segment that it runs into. So you have those perpendicular bisectors, and then the important facts, or the one important fact, is that the circumcenter is equidistant from each vertex of the angle. So the circumcenter is equidistant from each vertex of the triangle, meaning, so in this case, what it means is that AM equals BM, which equals CM, and then I highlight them. And then the reason that I don't do a tick mark with these is just because we already used tick marks on the side here so that you don't confuse them. So all of those ones are congruent. So I'm going to write that. AM equals BM. So that's our one fact as well. So that's a circumcenter. It's created by perpendicular bisectors. Then we have an incenter, and it's created by angle bisectors. And then so you can kind of see the difference with the picture here. So now we have these angles that are cut in half, and then that means that those angles are congruent to each other. But then we do have an important fact similar to circumcenter, but instead of talking about these lines that extend to the vertex, we're talking about these little lines that extend to the side. So the incenter is equidistant from each side of the triangle. So you can see the side-by-side comparison here. So what we're talking about then is that these little segments here, the ones that extend from the incenter to the side, those are congruent. So we're talking about XM is equal to YM, which is equal to ZM. And I'm going to highlight those two so you can see. So we're talking about these ones. So those ones are all congruent or equal to each other. All right. So those are circumcenter, incenter. Now we have the centroid. A centroid is created by medians. And a median is created by a vertex connected to the midpoint of the opposite side. So this was the last one of the last ones that we looked at. So a median goes from the vertex all the way to the other side and it hits the midpoint. So it also does cut that side in half. Okay, so it is like a bisector when you're comparing to like perpendicular bisector. Yes, it's like a bisector, but let's compare a little bit because this can be confusing because we both, if we compare these two, we're both looking at this side being cut in half. But notice with a perpendicular bisector, we're talking just about this little segment here. And you can see it's a little bit disjointed, like it goes, and then it kind of curves a little bit. Whereas with a median, we're going all the way from that vertex to that opposite side. and we're hitting the midpoint of this side, and it's not necessarily perpendicular. So this isn't a 90-degree angle right here. So it's not a perpendicular bisector, it is a median. So it goes from the vertex to the opposite side, and it hits the midpoint, meaning these two sides are equal to each other. And then the median is the one that had the special relationship with a median. Remember, this one kind of had a lot. So the longer part, remember, is 2/3 of the whole segment and all of that. So I'm going to write that here. So AM, like this part here, is 2/3 of the entire segment. AY, so this longer part is 2/3 of the whole median. So this was all from our last notes. So we do have this in our last notes, but just to have it all in one spot right here, I'm going to write all of those facts down. So then the shorter part is 1/3 of the whole thing. And then remember that the longer part is double the shorter part, and then the shorter part is half of the longer part, and that applies to every median. So it's all right there, and we went over that in our last notes, and you're going to practice with that some more today as well. But those are the facts for medians. So that one probably has the most complicated facts to it because of those kind of special relationships that happen. So those are medians. And then the last one is created by altitudes. If you need to pause and catch up with those, just pause the video to make sure you have it all copied. So with altitudes, an altitude is created by a vertex connected to the opposite side so that it's perpendicular to that side. So kind of now like the perpendicular ones over here, but they're not necessarily bisector, so they don't necessarily cut those side lengths in half. The only thing we know is that they're perpendicular. So an altitude is created by a vertex connected to the opposite side so that it is perpendicular to that side. And then with the altitude, that was pretty much it. So you've got, let's see. So it creates these perpendicular angles right here. And notice, they're different in length. So you can kind of tell like they're all different lengths. These ones are all different lengths too. So that's all we really say about the orthocenter. And let's see if I can just kind of highlight. I want to highlight each altitude so you can kind of see here. Altitude, so it's going from the vertex all the way to the other side, like that. And I'm not necessarily saying that those are congruent, but I just want to show you the altitudes. And then same with medians. Your medians go all the way from the vertex Okay, so that's just a graphic organizer so that you have all of those just next to each other so you can kind of compare a little bit and use that as a study tool. And then the next thing I'm going to go over with you is just a name that center practice. So I am going to move this away, and you should get a worksheet as well that looks like this. Name that center. So I'm actually going to go over this with you. Pause if you need to get this out or get a copy of this handed to you. I'm just going to go over these problems. So name that center. Okay, so hopefully you have this out and it's helpful maybe if you want to also, just have your graphic organizer out as well, so you can kind of look at those. So let's look at number 1 here. What I see, the first thing I see when I look at this is I see all of these as angle bisectors. So I see them cutting these angles in half and creating congruent angles. So if I look at my graphic organizer sheet, I see angle bisectors, and that is incenter. So the type of center that I would have here is an incenter because we're looking at angle bisectors. So no, it doesn't matter that it doesn't look exactly like this picture. In this picture, we don't have our sides drawn here that are creating 90-degree angles or perpendicular. We don't have those drawn, but that's fine. So if you ignore kind of that green part, you're going to see pretty much an identical match of this picture. So as long as you have those angle bisectors, that's an incenter. Oops, I spelled that wrong. Incenter. And then, so it's missing those, and that doesn't matter. Like if I just drew those on this picture, they would still be there. And this is all you see. So I personally, when I do problems like these, and you can kind of do them however you want, I go, I'm like, okay, if that's an incenter, can I look at this page? Do I see any that look just like that I can also label as incenter? So if you kind of look at the page, and that's just how I like to do it. You don't have to, you can go right through in order. But if you look, since we're dealing with incenter, I see one that looks just like it with the angle bisectors. Okay, so I'm going to label number 9 also as incenter. So number 9 just looks just like number 1, so it's also an incenter. So now there might be another incenter on here, but I'm not going to. There is one that's an incenter, but it looks a little bit different, so I'm not going to go over that one just yet. But this is an incenter. And the way I know that is these angle bisectors. Okay, let's take a look at number 2. So with number 2, I have a triangle here, and I can kind of see that these lines are extending all the way from the vertex to the opposite side and creating a perpendicular angle. So a 90-degree angle. So you see how this goes all the way to the vertex to that side, from the vertex to this side, and from the vertex to this side. So what that means is that is an orthocenter. And then let's compare for a second, because you might say, oh, okay, so if I see 90-degree angles, then it's an orthocenter. But no, that's not the case. So let's compare. I see 90-degree angles here as well. So I'm thinking, oh, okay, is that an orthocenter too? But notice how these 90-degree angles, it's not extending from the vertex. So it doesn't go from the vertex all the way to the other side. It just goes from the center here. So that's the difference. This 90-degree angle, it's created by this line that's going from the side all the way to the vertex, making it an orthocenter. Okay, let's look at another one here. So now we've got this one. We're going all the way from the vertex to the opposite side, and we're cutting that in half. Okay, now, so when I say cutting in half, I'm usually talking about a bisector, but I don't see any perpendicular bisectors here. I just see this going to the half. So what does that look like? So I see, to me, those are medians. So they're going from the vertex to the other side. They're going to the midpoint of that side. So it's like each of these is a midpoint. So that would be a centroid. Okay, and now number 4 looks very much like this triangle here. So I have these perpendicular segments here, and they're also cutting this in half. So they're perpendicular bisectors, meaning this is a circumcenter. Okay, so number 5, this is going to be a little bit tricky. Number 5, what it's showing me is that all of these segments here that are going from the vertex to the center, that they're all congruent. So all of these lines are congruent. So what that actually is, so remember, when we look at these facts here, this is what it's bringing up. In a circumcenter, each segment that's going to the vertex of the triangle is congruent. So if you actually look, we're looking at the green highlighted parts here basically, and this one is actually a circumcenter. So what it's just highlighting in this image is that the segments here that go from the vertex to this center are all equal to each other, which is what happens in a circumcenter. And so you're looking at these two pictures, they're basically, if you were to overlap these triangles on top of each other, if they were the same one, you would just have these lines that aren't drawn in this one, showing that they're all congruent to each other. Okay, and then number 6. You have a centroid. So you have these are extending from the vertex and they're going to the midpoint here. So these are halfway through. So those are medians and it is a centroid. On number 7, they're showing us now, this is kind of like number 5 here. So on number 7, they are showing us that these segments here that are perpendicular to the sides are congruent. So in one of these cases, it says that the incenter is equidistant from each side of the triangle. So if you look at the highlighted part, that's what it looks like. So showing that these are congruent, that's what this is showing. So this one is an incenter. So here's a question, let's compare. If I look at my triangles, these look kind of similar to each other, right? There's the perpendicular lines here. However, it's not showing me that these cut these side lengths in half. They're not equal to each other the way they are here. And they're showing me that these are all 3 are equal and this one is not. So that's the difference. That's why this one's circumcenter and this one's incenter. Because naturally we want to say, oh, well, if I want to look for these 90-degree angles and just pick one and make it simple, but it's not as simple as that. So let's look at number 8. So 8, we have seen this one before up above. So we're going from the vertex to the other side and we have a perpendicular angle. So it's perpendicular, which means that it is an altitude. So that is an orthocenter. And then the very last one, we have these perpendicular bisectors right here. Notice though the perpendicular bisector, it doesn't go straight to the vertex, right? It just goes from the center, from the center, and from the center. So those are perpendicular bisectors. So we have a circumcenter.